Welcome, everyone, and welcome to the CFTT series. This series is dedicated to enthusiasts and scholars in the fields of computer science and computer engineering. In our series, we're privileged to have esteemed professors from across the globe. They shed light on pivotal yet under-discussed computer science concepts. These topics, although not commonly covered in academic curricula, have retained and even grown in significance over the years. In our previous session, we had the honor of hosting Professor Edip Seniorek from Poland, who provided an insightful exploration of recommender systems. Today, we are delighted to welcome Professor Mike from Northeastern University. He will delve into the world of design patterns, a cornerstone in software engineering and architecture. We encourage interactive participation. Feel free to ask questions and share your thoughts during the Q&A session following the presentation. We are proud to have a diverse group of attendees from aspiring students to seasoned academics, all united by a passion for computer science. Without further ado, let's embark on another enlightening journey into the depths of computer science with Professor Shah.
All right. Well, thank you for that wonderful introduction.
You're
And
welcome.
as mentioned, feel free to participate. And I just want to again thank the College of Harvey at Tehran University for having me. It's really my honor. Brief apologies on the technical difficulties, and I'm battling a little bit of a sickness, but we'll make it through. So, all right. And just to confirm, everyone can see my screen and slideshow. Let's see. Let me know if that is the case here. I see yes. Great. Okay. Try not to flip too much through things. Let me actually see how to best do this. I want to keep the chat window active here. Screen and slideshow visible. Okay, great. So I want to keep the questions up in here. So apologies if sometimes I don't go into full screen mode. Um, but I'll do the best I can to check on questions, or feel free to just interrupt. So we'll kind of flip back and forth here. So this talk is titled "Thinking About Design with Patterns," and specifically, we're going to be talking about the visitor pattern in C++. So I'm going to give you a little bit of a refresher on the C++ programming language for those who aren't familiar, though I've been informed that many of you are or have used C++, which is great. And originally, when I was designing this talk, I thought of it as sort of a cookie cutter, here's a design pattern sort of talk. And I would just sort of teach you, what the visitor pattern is. But as I started looking at some more design patterns and thinking about this talk, I've found that there's just a lot more interesting trade offs to be discussed and just how we think computationally. So that's sort of my goal today, to get you to think about things. So, with that said, I want to take a little divergent thought here and take you to a talk I wish I had written myself. This is by Andrei Alexandrescu. He's a pretty prolific programmer in the world of C++, as well as the D programming language and other areas. I wonder, have folks heard or know of Andre or have read any of his books? I think I'm going to keep flipping back and forth so I can find the chat window from Adobe Connect here. Have folks heard of Andre? I'm just kind of curious what they've heard of or learned, or maybe have seen his book. It is called Modern C++ Development, I believe. Um, if you haven't, it's an older book, so again, perhaps more from my time than from you folks. But anyways, he's sort of somebody who's influenced a lot of modern language design, specifically C++, and even languages like Java and other things that you might have used. But anyways, the point of this slide here is it's one of the best title talks in that it's called um, "That the Speed is Found in the Minds of People." It's a talk about algorithms, so you learn about algorithms and these sort of things here from this talk. And of course, that makes sense. How we think, how we approach a problem. That's, of course, where we're going to get speed, performance, and design, really good software. And I really love that emphasis that software is about people and it's about how we think, right? So there's often not a perfect or robotic sort of way to approach some problem. I know with the rise of artificial intelligence tools, we're going to have a lot of assistance in how we program. That seems like the inevitable trend, right? Again, maybe some of you folks have used ChatGPT or these types of things. But at the end of the day, we're still, at least for the time being, going to have to think about how we write software. And throughout this talk here, which you can bookmark or watch in the recording later, Andre talks about some of the different programming paradigms, object oriented programming, again, something that you're thinking about or learning in your classes, perhaps, or again, some of you maybe have worked professionally as well in this audience. Different other paradigms like generic programming, designing by introspection, and of course, there's functional programming, these things. So, again, the whole point is that software engineering is about trade offs. And when we want things, especially speed or performance or safety, we have to think about these things as people. So, that's what kind of informs this talk here. So, with that said, again, thank you again for the wonderful introduction that you gave. But again, I'm a teaching professor, again, based in the US and Boston. And again, I do a lot of C++ work. I do various teaching work, and I've sort of worked in the graphics industry as well. So that's my professional experience. And of course, I do a lot of educational content now on YouTube. So, of course, happy to be teaching and with you folks today. So, anyways, there is going to be some code that I will show for this talk. It will be linked on my GitHub. I will post it on my website. If you Google my name and computer science or Mike Shah professor, you'll probably find my website and you'll find a link to this talk after today. So you can try out the examples. So, anyways, what we're going to start talking about here, the goal is to talk about design patterns and software development. Again, thinking about the design patterns that we use can greatly simplify or improve the quality of the software that we develop. So that's sort of our goal, and to actually think about a problem and how we want to approach or solve a real world problem. So that's going to be our goal today. So hopefully that's what you'll get to enjoy here. So I want to go ahead and start off with a quick review of some programming paradigms. So, the same way that Andre told us about how we think about things, whether it's the sort of what's popular, meaning, maybe object oriented programming was very popular, or procedural, or functional, or whatever, those paradigms came with different tools. Okay. And we want to understand what some of those are and have a little bit of a common ground as we move forward in our discussion here. So, again, I'm going to be doing my examples in C++. So if you're familiar with Java, you should be able to follow along. But I'll point out a few of the sort of idioms or things that are in C++ that are interesting. But the important part is, again, that C++, like other languages like Java or D language or whatever, have different paradigms that we can pick and choose from. So that way, if we're going to be talking about this idea of design patterns, well, the paradigms that we use are also sort of like design patterns themselves. Okay, they're just different tools for how we're going to approach some problem here. So very briefly, I'll discuss a few features of each paradigm, and then we'll get into some more interactive stuff here. And again, feel free to interrupt me, just shout out if you have a question, and we'll continue from there. So, starting from the very basics here, we've got procedural programming, which is just solving problems with functions or procedures. So, some of the features of a language like C++, we have functions or procedures, as they're called in other languages, where you take zero arguments and produce maybe zero or more values. You've got some ways to structure your data to kind of work with things, structs, unions, enum classes, arrays, and so on. And some ways to, again, work with data with conditional statements, right, to make decisions. So these are sort of your basic things in a procedural language. So that's just sort of a list of things. But if we look at this from some of our tools that we have in code for how we approach problems, well, here's some examples with enums in the top right. So these are a way to just sort of group things together, squares, circles, pentagons, and so on, of the sort of related things. And over time, languages have evolved to give us some more safety with these features. So we have enum classes in C++ that are a bit more strongly typed. So maybe we have the state of some thing like a computer running, or it's off or paused, or an error, like me getting set up today. So we have different states there. And we could use these different tools, for instance, in functions, which again are the important part of procedural style programming. So, for example, we might have a function that takes in some sort of shape and have some conditional logic here to handle each case of our enumeration. Now, as mentioned, we probably want to do something a little bit better, which is like this function below, which uses the enum class and, well, it ensures if we turn on our compiling warnings that we handle all the cases here, right? That we handle the different states for running, pause, off, or error. Okay, so we get some, again, added advantages here with some of these different tools here. And then there's some other interesting stuff we could do with, again, how we structure our data, the data that's being passed around in these functions, like if we have an event here with unions and structures. And again, I'll leave this code for you to take a look at here. But again, these are just some interesting things with passing data in a compact way here. Okay, so union of structs is something we might look at. So that's sort of the procedural stuff. And again, let me keep my chat open here. Let me close down some of this other stuff here, um, just so we can take a look here. Yeah, please raise your hands. Okay, yep. I'll just check in on that every once in a while here. There we go. So that's procedural style. And our object-oriented programming is sort of the next popular paradigm. Again, this is putting your data with the code. Okay, so this idea that we're going to group together, well, whether it's a union or a struct with some behaviors. Uncommonly, for those of you who've taken a class on maybe object-oriented programming or learned it, you're probably tested on these ideas of encapsulation, inheritance, and polymorphism. Okay, so some different ideas here again, with encapsulation being this idea that we're going to combine things together, the data and our behaviors. Okay, that sort of forms a nice little way for us to think about the world again, because our world, well, that we live in is sort of composed of objects or things that we interact with. So we might think about, again, their attributes, how much something costs, how much it weighs, how durable it is, or whatever. And then the behaviors we could do with something like a car, right? We can drive it, steer it, play music, etc. And encapsulation, in ways that we could put things together, like objects and classes, allow us for abstraction as well. So whether we want to just think about things at a higher level, right, just thinking about the object or hierarchy, as well as getting rid of some details that we don't need to think about, right? If we're just a client of someone else's code, we can hide information, make things public, private, protected, etc. And then, of course, we've got inheritance, which is our ability to derive new types with some sort of, is a relationship. Inheritance folks often think of as a way to reuse code, but it's really about building a relationship between objects, right? If we have different cars, for example, different car brands. So Toyota is a car, Ford is a car, etc. That's the sort of relationship that we want to preserve. And inheritance also allows us to derive new types to some interface so that we have sort of strict requirements of what we want to do. Okay, how all cars must drive, for instance. There needs to be some common interface. And then we've got polymorphism as another attribute of object-oriented programming. Again, there's different types of polymorphism. There's a type functional polymorphism. Again, even though it's functional overloading, calling functions with different types of parameters. There's a polymorphism related to inheritance, where at runtime we could choose any type of car, whether it's a Toyota or a Ford or so on to use. There's compile time polymorphism and all sorts of different types of polymorphism, but that's often something that we have in an object-oriented language. So again, some concrete examples just to get everybody on the same page here. With encapsulation, here we are associating some data here, the name of some actor here, Golshifteh Farahani, maybe some of you have heard of. But this actor object has some data, their name, maybe their age, what movies they've been in, and behaviors that they can have. In this case, I just have they can print their name. And of course, we can hide some of this information and abstract it. And we generally think of this as pretty modular, right? I should be able to just import or include your file that has this actor class and be able to use it, right? The behaviors and the data are all sitting together. So that's the idea with encapsulation. Now, with inheritance, this is our ability to, again, derive a new type. So, again, excuse me. This is the idea that if I have some actor here, well, there's different types of actors, but I might want them to behave a little bit different. So I might have a method actor or a classical actor or whatever the different cases might be, or some actor with no experience, just different types of actors. However, I want to categorize them. Maybe they're virtual actors, maybe they're 3D animated characters, maybe they're real people. But that's the idea that I can derive a new type of actor and change their behaviors, okay, based off the inheritance. So just looking at some of the details as far as how C++ does inheritance, some interesting things here. If I look at this class for an actor, so looking at line 8 where my cursor is, I've renamed it with a capital I, just a good thing to do with naming here to indicate that it's an interface. And what makes this is an interface, meaning that it's sort of a base class that we're going to derive or create new actors from, like the method actor at line 22 or the classical actor at line 33, is that we have these virtual functions here. So drawing your attention to line 15, I have virtual void practice equals 0. Again, this looks a little bit weird in C++, but this is how we do things. But this is basically saying that this function has no implementation in this interface, and that we must implement it in any derived class that we have. So for our method actors or our classical actors, here we must implement the different behaviors, how we practice acting here, okay? So that's just an example there. So we call that a purely virtual function in C++. And the idea is, depending on our actor that we have here, let's see if I've got a slide, here we are, which is related to the next concept of polymorphism, is that if I just create any actor, so I'll draw your attention to line 51 here, actor, say S, and I can instantiate them as a new method actor, call practice, and it'll call the appropriate function that we are doing, well, the method actor version of practice, versus if I delete this object and later reallocate it as a classical actor, we could practice and get called the correct function here. Okay, so this is the purpose of a virtual function and this idea of dynamic dispatch. Okay, so just a quick poll here since I've been going on. Let me bring up the chat window here. Oops, I'm gonna wrestle this a little bit here. I guess I'll just exit full screen mode here. Bring up the chat. How many folks have heard this term virtual or dynamic dispatch here? Is that a familiar term for folks? Let's see, I'm seeing some folks typing. Haven't heard of it. Okay, great, great. Well, I'm glad we're getting everybody on the same view here. Up. And let me, here we go. I should have my, there I am. Now I'm actually on the screen as well. So you can see me smiling. Let's see, the virtual keyword, yes, great, 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 okay. Okay, so we're gonna have some fun with this then. This is great. Let me just hear some other folks' thoughts here. All right, give some folks some time to pause and enjoy here. And feel, yeah, like dynamic binding, yeah. All right, so if you've heard it in Java, you might have heard it by that term, dynamic dispatch, dynamic binding, some of these different terms here. Great, great. Okay, so I mean, let's take a look at this example here. And let me, again, Let's go to full screen here. I want to maximize the code you can see here. But again, just interrupt me at any time. Again, there's this virtual keyword basically says we're going to select at runtime the correct, again, practice function to call here. That was the idea here. Okay. So again, if I move forward here, right, practice, we have the method version and practice the actor. Okay, so for some of you who know about that dynamic binding, this sort of same idea, right? And what this allows us to do is just say, hey, I don't know what type of actor I'm going to have here, right? Maybe it's Mike Shah, maybe it's somebody more famous like Golshifta Farahani. And then at runtime, I'll decide that they're a method actor, or maybe they're doing a new movie project and they're a classical actor. Okay, so that's kind of the advantage I get here. Now, behind the scenes, this uses something known as a virtual table to figure out which exact function to call. Okay, and I could provide some resources at the end. I think we'll have time for Q&A at the end too. If you want to learn more about those things. Great interview questions to know about for those of you, again, looking for software engineering roles. So something good to know about. Okay, so let's go on to our final paradigm here. And again, as I just do a quick look at the questions here, don't see anybody typing. Functional programming is sort of another popular paradigm. And again, there's many other paradigms, generic programming and so on, but this is the idea that we're going to use primarily functions to compose new behaviors. Okay, so you might have heard of some of these things like lambdas, higher order functions, or the ability to pass a function within another function. Right, this is something you probably learn about in your math class here. You know, f of some function, take another function as input. And there's this idea that usually you have some function with a specific input and it generates the same output. So you could do interesting things in terms of your computer science, in terms of caching a result. So you only have to compute things one time. You tend to copy your data versus mutate your data a lot, which is a very popular thing in the C++ world right now, known as value semantics. We're trending towards that because it can allow for safer, more correct, more manageable software. Okay, so anyways, that's some of the ideas here. We have some other things like avoiding mutation, type safety, but even ideas like pattern matching. In fact, if I go back a slide, you'll see that there's some overlap here. Let me go back all the way to procedural programming, which is kind of the old style here. We kind of had a little pattern matching thing here, right? Where I have an enum class and I say, hey, here's a state here, and I want to switch on, well, if I'm doing this sort of pattern running or paused or off or error, right? We sort of match to the right thing in our state here. Okay, so that's getting to some. And again, the idea with functional programming is it's just a different. This example here, I've data here, some structured data. Now I do have a member function. That's okay. We'll forgive that. But I might have some function here, like an agenda of things that I want to do here. Okay, so maybe I need to practice or dance, and these are lambda functions here. So I can just define these functions. They could have a name or not have a name, but I'll assign them to practice or dance variables. I could create an actor. This time, lucky, it's me for my acting. And I could pass into this function here another function that I want to call and on the data that I want to act on. In this case, myself, this actor. Okay, so I'll do practicing on this actor, dancing with this actor, and I could compose some different behaviors with this. Okay, so that's the idea. That's just a different way to think about things. And again, if I'm being good functional programmer, you'll notice there's more const data, so things aren't changing. State's not really changing. I'm producing maybe a new value through some function, but I don't often change state. That's sort of the goal of functional programming. So we'll hold on to some of these ideas here with our functional paradigms. Okay. So, hopefully this is a little bit of a refresher for some folks here. And I'll leave the questions open if you have any here. But again, these are just different ways for us to think about how we program. Okay, procedural style, object oriented, functional. Again, some of you might take different classes or watch different videos or learn from other instructors in this great series that you have about different paradigms. Okay, it just helps you think about things differently, which again is the important part, right? Remember, speed comes from the mind of people. All right. So let's get into something a little bit fun here. And I'm going to have you do a little exercise in a moment here, but I want to take a real world application here. Okay. And hopefully it's not too scary. You can see my little character here, this guy here. But I'm going to use a game as an example because I love playing games, whether board games or video games. Um, and I think it's useful to think about software development with some real world applications here. Okay, so I'm going to show a project. Disclaimer: I didn't work on this particular project, but I know a little bit about it from talks and just software development. But I think it's a good example. So a real task in gaming, and let's say I'm going to hire one of you, my gracious participants for today, at a video game company. Okay, so how fun. Now, here's the catch though. You're going to be joining as a contractor or consultant in the project. And I'm going to be asking you to sort of extend some behavior of the gameplay. Okay, so that's going to be the idea here for this particular task here that you've been hired for. Okay, I'll pay you virtual dollars to do this. All right, some sort of currency. So again, first and foremost, let me bring up my poll here. Does anybody know which game this is? Let's see if we have any folks playing video games on your computer, or maybe you'll recognize it from some movie. Um, Way too old, yeah. Yeah. I know, I'm dating myself a little bit. This is from the 2011 2014 era. You folks have cooler stuff now. And me, I still play games. Let's see, is that evil? Something related? Yeah. It's based off a famous book, too. I'll give you a hint. Famous book, I should say, in the US and in Europe more so. But the films, I think, have made their way around the world and have been translated. So let's go ahead and take a look here. Oh, we got one more guess maybe coming in. Yeah, let me just move to the next slide here. See if folks have heard of it. All right, it's from this series, The Lord of the Rings. Have folks heard of that? Or maybe seen the movies? Let's see. Let's see if I picked well here. Sure. Okay, great. Some folks have heard of it. And you should go watch the movies or maybe look at the game if you have a chance. Probably one of the more popular, between Mario or these types of things. But this is what it's from here. Great. Okay. So, anyways, the point of this game is, you kind of explore and you do combat and, with these virtual characters and help people and so on, which seems like a good mission. Um, but so that's a little bit of the background here. Now, here's some of the characters that you might encounter in battle. Okay, and maybe they're friends, maybe they're enemies. We'll call them as characters that you're battling enemies. It's all about your perspective, I suppose. And they have different strengths or personalities. They've got their own lives, these two gentlemen here. um, so, and there's a vast number of them here. Okay, so here's just some screenshots from the game here. Again, you can see all these different characters here that you have to battle and, win points or whatever. And they have their own different behaviors. That was a key feature of this game, that each of these characters have their own personalities and motives and so on. So, anyways, you could, again, read through the wiki, which goes through some of the development. And if you look at this project on YouTube, one of the reasons I picked it is there's a lot of talks about the actual software engineering in this project. I encourage you to watch some of those by other folks, other engineers, and watch them multiple times over your career because you'll get something new from each of them, which is very nice. But again, as you can imagine, remember our task at hand. I've hired you, and well, you're coming in this project, and there's maybe hundreds of thousands of lines of code, millions of lines of code are not uncommon for a video game, whether like this or others that you might see. So it's a significant project, right? 3 years of time invested in it, and hundreds, if not millions, of lines of code. Okay. And there's some really cool systems. Again, you have to read the Wikipedia on this. I think you'll find something that you enjoy or you can learn about. And again, if you're not interested in video games, that's also okay, right? Just pick another piece of software and you can run through this exercise. But I thought games would be a fun one for today. But let's go ahead and give you a little bit of a task here to think about. And you can type this in the chat here or, just kind of think out loud. But I want to give everybody a chance to think about if I've got these two characters here, and you can even look in the screenshot, what sort of attributes do they have? If you're writing a class or a structure or a record of data, what things do you think they should have? What does it look like in code? And you could just list some attributes um, that you think might be fun or that you see in the picture here. What's part of these classes? Okay, and I'll read some off as they're coming in. And feel free to add or repeat. They've got damage, health, a name, a weapon, which might be a class in itself. Yep. So we might want to compose various things. We've got the textures, yeah, the actual 3D model as well, the mesh we call, weapon. What else here? The hit points, yep. Yeah, okay, great. We're getting some structure here in the chat as well. Hopefully that's captured in the recording, but again, I'll read out. We've got a public class, maybe we'll call it an enemy with their power and stamina. Great. Yeah, someone noticed that there's power in the picture here. Hit points or health points. Yep, HP. Great. Yeah, okay. These are all reasonable attributes, right? And this is the kind of exercise that we would do kind of designing this. Great. So let me move us forward here. And as you folks mentioned, and somebody even gave in the chat, right? We might have a class. It might be called enemy. Maybe it's even something more generic. Maybe it's just character, right? Because again, depending on our perspective, maybe they're friends. Maybe if we can play on their team or whatever. And then we've got these attributes that many of you listed, right? Their power, their rank, motive, attack, agility, hit points, all those things. Their name, right? Their story that they have here. Okay, so in code, as somebody sketched out in the chat very nicely, right? You probably have some sort of class here, right? Maybe we could call it enemy, maybe it's orc, and then you've got these different attributes here, right? And you could see how some of them maybe map to the actual picture, or otherwise, someone else mentioned, right? Maybe these are better fit for their own class, right? Like a weapon or something. Okay. And that's exactly what we might want to do here in the next slide. So I'll leave this here for a few moments since I flipped through those relatively quickly. But the idea is we might have some class that looks like this. So as I'm kind of circling around line 21, we've got a class with an orc, right? Maybe some way to construct it. And then we've got some data. And it's probably a good idea to wrap up that data in its own structure. Because then we just have all the attributes together. And again, maybe there's a weapon that this object can hold, or an outfit, or we could be a little bit more optimistic. Maybe they have a device to help people or something. However we want to think about it in this game. But this is kind of interesting. I mean, this is a relatively clean design too. If I'm just looking at the class here with an orc that has some attributes, okay. And this in itself is kind of interesting as I'm just thinking about this aloud, or what's on the slide. Because if I look at this design that I've changed from the left, and I did that relatively quickly by just wrapping up all the attributes in their own struct, we could start to do interesting things with other paradigms that you might learn about or hear about, right? These attributes could be in a pointer. They could be hidden. There's something called the pimple idiom. pointer to the implementation. That's kind of neat because I can now change all the attributes, but it doesn't really affect the layout of this org here, which is kind of neat. Um, and well, the other really interesting thing that I've done here is, and let me just move to the next slide here, is what I've done is I've just moved out the data, right, which was part of this sort of object oriented paradigm that we've done, into its own sort of structure here. So I've still got the data associated with the behaviors, but in effect, I've moved out a lot of it here. Okay. Um, so now it's not sort of dependent on this org structure here. Okay. I've extracted out the data. So the thought that I want us to hold on to, and let me make sure I leave our questions up here if there's any for why I did this or anything of that, is if I'm able to move my data out of my class relatively easily, what about my behaviors? Okay, and that's something that I haven't asked about yet. When we were doing this little exercise, again, if I uh, scroll up here a little bit here, well, about to here, slide 32, let's say. These two characters are different. They might have different behaviors, right? Maybe this guy's a boss or some sort of general. Maybe this guy, well, he looks like he might be a chef or something. Maybe he cooks the meals, right? So they're going to have different behaviors. I wonder if there's a different way that I can sort of move those behaviors just like I move the data out of the class. And what does that actually do for our software design as we think about this? So let's just kind of hold on to that thought. Because again, I think that just is an interesting idea of being able to move data around as well as the behaviors. Now, when you learn about object-oriented programming, we sort of learn about adding functions to a class, and that's where they sort of belong, functions or methods, you might know them by. But what if I didn't have to do that? What if they could be a little bit more free? Okay. So okay, so let's keep moving with this design problem a little bit, and we've got our cast of enemies to work with. Okay, or again, however you want to categorize them. But here are from the Lord of the Rings, different characters here. I've got different types of orcs and goblins and so on. This is a relatively fixed set, which is actually important for our problem today. That we've got 8 sort of known characters. I'm going to focus on 2 just for the purpose of the code example. Just for what can fit in a slideshow presentation here, right? We've got some goblins and we've got some orcs here. Okay. Okay. So, what problem am I trying to solve here? The problem is, again, that I've brought you on this team here. Maybe we're a year into the project, hundreds of thousands of lines of code, and I want you to extend the behaviors of goblins and orcs. Okay. And I want you to do this in a way that doesn't mess up the code base, so to speak. So this is where we're going to need to think a little bit here. Now, I've already shown you one mechanism which we can do this. Again, going back a few slides here, where we move the attributes into their own structure. That's going to sort of be the same or similar idea that we want to do with our behaviors. Okay. Okay. And again, as mentioned, we want to make sure that however we design or solve this problem, we do it in a way that's flexible. Our code base is maintainable, meaning that somebody else can understand our code and modify it. And again, we're extending the behaviors here, right? We want to make this relatively clean for us to do. Okay, now another little exercise for folks here. Let me bring up our questions. And folks are already thinking about it, is to think about how we'd lay out the hierarchy here. And I've already got someone thinking about, let's see, SMJ, thinking about interfaces for common behaviors. Great. And implement the interfaces instead of the subclasses. Interesting idea. Maybe somebody's done some object-oriented programming here. Very nice. And we're going to have an exact pattern for this. But the little exercise that I want folks to think about here is, what does this structure look like here with orcs and goblins and maybe other orcs or so on. So you could, I'll just give you a few moments to think about this And again, think about your object-oriented programming here. And the comment is, I mean, they are all creatures. Yep. So we might need some sort of, well, the thoughts keep coming in. A little clue, perhaps. Yeah, I'm just thinking about just a basic object-oriented hierarchy. In fact, I'll show you in a slide in a moment here. Um, well, let me just give you the clue here. Because I bet if you were going to design this, right, from scratch, this is what you would do, right? If you're writing this, if you just open up a new um, code editor and start typing out the code, I bet this is what you'd do. Now, let me let some folks finish their thoughts, though. Can you use decorator pattern? Oh, interesting. Okay, so some folks know about some patterns here. Yeah, we could do something like that, right? These are, we're going to see that there's many ways to solve this problem here. And they all come with their trade-offs. Okay, interesting. We've got a state pattern here. Okay, so we could think about maybe what um, objects we're working with and put them in a state here. And then let's see, SMJs come up with a hierarchy here to have a class with a creature that has evil ones and good ones with hobbits. And so, yeah, I think, yeah, let me kind of mimic this here. I'll give you the simplest hierarchy here. Right, let's just have a monster or a creature. We could even rename this and have goblins and orcs under it. Okay. We'll work with something simple, but exactly what you have there is probably what we want in this, large project, right? Maybe evil, maybe good. Now, again, we might even want to think about how to flatten the hierarchy more beyond evil and good, and just have those be part of the behaviors. Um, you know, we're using this tool that we know about in object-oriented programming known as inheritance, but we've got to be careful to not overuse it, which is something we always want to be careful with in these patterns here. It's sort of fallen out of favor here. Yeah, it can be limiting. Correct. So let's kind of move forward here. Let's see what this looks like in this hierarchy. And I mean, well, we've had some thoughts here, but I'm asking the question on the slide. What do folks think about this design here? Right, we've got a struct here with the monster, the orc that inherits from monster. And I'm going to give it this behavior. It's pretty positive, singing that we must implement. That's what this virtual void function is. And then a goblin, which inherits from monsters, so it also must sing. And then maybe we create a collection of the monsters, create the orc and the goblin, and then we basically loop through all of our monsters, the one orc and the one goblin we have, and they call their appropriate singing function. What do folks think about this? It uses inheritance, yep, which is fine, right? It's a tool that we can use. Might be hard to navigate through with more classes that we might implement in the future. Yeah, so as mentioned, right, if we want to add, trolls and dragons and other sorts of objects, we might have a lot to deal with. And as mentioned, we might want evil and good as well in this sort of structure. And we could use a factory method for making the creation easier. Yep, yep. We could certainly do that. Yes, somebody did notice there is a typo at line 27. That should be Goblin Sing. I'll make sure to correct that in the slides and the code. And yeah, the idea of the factory, right? So for lines 34 and 35, and again, this is as you folks learn more patterns, you might think about how how to create things so that we don't create errors, right? This is lines 34 and 35 for those who aren't just familiar with C++, is constructing the object in place in the vector. We probably want some factory or some function that we can call that just creates a particular orc or goblin, and maybe we supply attributes and so on to that factory, just so it's a little bit more uniform, right? And that's a creational pattern that we can use. So yeah, these are all great ideas that folks are sharing here, right? And this is what we do, right? We review code, we think about it, because as you're years into our project, you often have to commit to an idea and can't really move forward here. So let me move forward here, and I'll give my sort of review again, just highlighting things, and then I'll hear your thoughts. But again, we have this interface here for a monster. That seems fine. Programming to an interface, usually not a bad thing. And then we've got, our different classes that do different things. Maybe we'll want these orcs to battle or to render them and draw them, etc. But for now, they're singing, right? Maybe they'll cook or whatever. And they could have their own exclusive methods if we want. But they must have at least sing, and they're doing that. Now, this is a little bit worrying. And maybe I'll actually, as somebody noticed at line 27, right, I made that mistake of the orc singing here. Well, this looks like a copy and paste. So this is like this other principle we have, don't repeat yourself, sometimes called the dry principle. And this is what happens sometimes when you implement code that's, copying and pasting or doing the same thing, right? If you do this too many times, well, you run into these errors like I've done here. So whether that was intentional or not, I'll leave that up to you. But that is a problem here, right? Or potentially a problem. And it's especially a problem if orc and goblin and troll and dragon or however many other classes we create are in many different files here, right? Where we've got to remember to implement sing and all these other member functions. So that's not great. We might want to improve that. And then the other thing we need to consider though is if our orcs or goblins, we do need to make sure that they have these sort of sing functions here. We might need to combine this with some of the stuff we learned earlier, maybe having a switch statement on the type here. If they are not all able to sing or do something. Okay, so if we might want to wrap this into a function itself to make all the monsters that can sing, and so on. But just some different things to think about. This code overall isn't bad per se. Okay, it's reasonable for this scope, right? This tiny little snippet here. But again, what I want to be clear about is this hierarchy is fine. We could have inheritance here. That's fine. Inheritance is a fine tool to use. When we know what it's doing. But I am going to want to look for ways to extend this class again over time. And again, we're sort of putting ourselves in the mindset that we're on this project for a very long time and have a lot of code to maintain here. So what if we want to do things like add the ability for all monsters to do different things like battle and so on? Okay, so for our goals for today, we want to sort of implement this pattern here. I'll kind of move through this quickly, but the basic idea is, we've done our programming review. I want to show you what design patterns are, and then I'm going to show you what the visitor pattern is. Okay, and it's not an expert level pattern, but it is a good, I would say, intermediate level pattern for you to understand. Okay, whether it's in Java or C++ or whichever language you choose. Okay, so design patterns, just a quick introduction, is it's been popularized primarily by this book. I would still recommend this book. There are newer books, as I've listed here. This is Andres Alexandrescu's book, as I mentioned. This is a pretty good one as well. That's modern with C++ 17 and 20 stuff. But this is the old Gang of Four book, because there's 4 authors, that has about 23 patterns that are popularly used, okay, in software. So again, good to study and to know, because you'll see these things show up in software. I'll also note that this is also an excellent book, Game Programming Patterns. It's free. So, again, if you're a student in the audience here, free is good. So you can enjoy this. And I'm not commissioned or paid in any way. I love this book so much, I bought a physical copy that's literally by my bedside right now as I was preparing for this talk, learning about different patterns. The visitor pattern that we talked about today isn't in it, but there are other patterns that you could use to solve today's problem. So, anyways, design patterns themselves are these sort of known ways to architect or design software, again, to hit these features of being more flexible, maintainable, or extensible. So, uh, I would say one of the main things that this book contributes is the sort of collection of patterns as well as the categorization or taxonomy of these patterns, being creational, structural, or behavioral patterns, for instance. And we're going to focus on a behavioral pattern today. This is going to be the visitor pattern, as I've mentioned briefly. So you'll see visitor here. And you'll see it has something to do with adding operations here. This is actually a really nice picture if we take a look at it. It's more than just a listing of the patterns here, but you can see what it's sort of used for, or patterns that are nearby, which ones you might use. Okay, so anyways, we're going to focus on behavioral patterns and specifically the visitor pattern. Okay, so you could go on the wiki page for design patterns and find nice descriptions of these as well. Okay, so let's get to the visitor pattern here. What is this all about? So the visitor pattern is a behavioral design pattern, and behavioral patterns sort of focus on the communication between objects. Visitors a little bit less so in that category, in that it focuses on adding behaviors itself. Okay, so the definition from the book here of the visitor pattern is we want to represent an operation to be performed on elements of an object structure. Okay, so what does that sort of mean? Well, we basically just want to abstract out the functions that will act on different types of monsters. Okay, they'll have their own class. Okay, so what this is sort of ideal for, if you read the rest of this description, is building a application programming interface or sort of plug-in system where I can just add behaviors, right? Whether I'm the owner of the source code or maybe I'm modifying this project. Maybe I'm an artist or a designer who wants to also add other behaviors. Okay, so it's very amenable to allowing us to add behavior to our objects without having to modify necessarily the C++ code. Okay, so this is kind of cool here. Okay, so let me take a brief moment here to see if any questions. That was sort of the fast version of design patterns. But I think we sort of get the idea that these are recipes, these are known solutions that you can try, right? They're not going to be perfect necessarily, but they're common enough patterns that they're usually a good starting point, and sometimes the exact solution that we need. Okay. Okay, so let's review again our first solution here, but apply the visitor pattern to it. Okay. And again, in the same way that earlier when I was just showing you how we might simplify some of our code, that I wanted to move all of my attributes in their own struct, I'm going to do the same thing with all of my member functions. I'm going to move those all into their new class or struct. So here's the sort of diagram. I'm going to ignore this. This is something that's useful to stare at after you look at the code, I think. Then it makes a little bit more sense. This is a unified modeling language or UML diagram. But let's build this up slowly here, okay? Because this is what we had here, right? A goblin and an orc, and they inherit from the monster, right? That's what this code was doing here. But what I want to do here is create this visitor class here, okay? And it's going to be the monster visitor because it's going to be for monsters, okay? So that's why we have this name here. And again, the purpose of this class is going to be to actually hold the different behaviors that we can apply to goblins or orcs, okay? Now looking at this pattern, again, it's not always intuitive. That is one of the drawbacks. It seems a little bit, until you know it, I would say it looks strange. But again, what we're doing here is creating this structure for a monster visitor. So I've got here some way to visit orcs and goblins, okay, from this monster visitor class. And you'll notice again, this is in C++, a virtual void function that we set to equal to 0 means we have to implement it. So it's an abstract sort of class here. And basically, this is using composition or passing in data, our orcs and our goblins, into some visit function that's going to define some behavior. Okay. All right. So that's a little bit of a mouthful, but just keep in mind we've got our hierarchy here with monsters still preserved. And then I've added this new class that says, hey, we're going to allow orcs and goblins to visit, okay, or enter in. Okay. So now what we're going to do is derive from our monster visitor the new behaviors. Okay, so maybe we want to draw, or maybe we want to fight, or maybe we want to sing. So we'll create a visitor class for that. And those are all going to be derived from the monster visitor. Okay. So that's the idea here. So we've got this sort of separate hierarchy over here of different actions, right? These are the actual member functions that we have for drawing and fighting this particular hierarchy, monsters. Okay, and they're named appropriately. Draw, monster visitor, monster visitor. Okay, so the interface or how I connect these is now my monster base class has a way to accept different behaviors. Okay, and that's sort of the way to read this. It's a little bit weird, but most of the code that you're going to read is going to follow this notation. You just have to think about it a little bit, that we're going to accept this behavior, this thing that's allowed to visit, because it doesn't belong to this class, right? It's in its own hierarchy. That's why it's a visitor. But it is allowed to be passed into it, and we'll accept specific types of visitors, right? We could have monster visitors or artificial intelligence visitor or file system visitor or whatever that aren't directly related but add some sort of behavior to these goblins and orcs here. Okay, so let me pause there for a second and see if this is making sense this far here, as far as questions go. Any questions about this? Makes sense so far? Great. And a little confused. Yeah. Okay. Yeah, so the comment is, I'm a little bit confused. Is this to make it neater and more restructured? And I'm glad you're asking that question, right? There's no bad questions today, by the way, so ask anything. I would argue at this point, this has not really made the code clearer in any way, right? Why not just add draw and fight and these, member functions here? And in fact, that would probably be easier to understand in some ways. So, what this is doing, what the purpose of this pattern is to make all of our behaviors, or otherwise, if we've got an active hierarchy, again, you're a year into the project, is to make it easy to extend or add behaviors to goblins and orcs without modifying these classes necessarily. Okay. The power of that is that, again, you could design a system, in particular in a game, where an artist or a designer could build a plugin, right, where they just basically write their own visitor class, right, and they don't modify the structure of goblin and orc. So goblins and orcs stay pretty stable. They don't really change, which is the great thing. They just accept new behaviors as we need them. So in that way, it's really great. So in that sense, it does become neat and structured in the sense that, this right side of the hierarchy with the monsters is basically, this is basically it. We have this accept function and then the data that belongs to goblins and orcs. So that way it's very clean. But then we come up with sort of more of these classes that are isolated or sort of insulated, that have the behaviors for drawing and fighting and so on. Okay. So yeah, the original class would stay in touch, which means less trouble if potential problems occur. This would also help in updates and patches. Yes, correct. Yep, because I can then have a patch or an update that says, hey, uh, monsters can not only be fighting, but they could be fighting and singing, right, at the same time, or chanting, or whatever the equivalent is. That's sort of an idea here, right? I could add on that behavior without having to potentially, when you start modifying the structure of goblins and orcs, the data layouts and things that can start to cause some problems. Okay, so the comment is, so this pattern lets us easily extend and improve the code over time, like we want to give an update to the game and things like that. Exactly. Yep. From Madi, that's exactly right. Perfect. All right. But the functions would have to be run in the original class. Yeah, we're going to see the functions for orcs and goblins actually just will accept also um, a visitor, right? Because we have to implement this function, right? Monster. We've got this function that we have to implement here on accept, but they'll basically just call the visitor class, whether it's how to draw things or to fight. Yeah, perfect. So let me go ahead and move on and actually show that. Oh, I see one more question coming in. Perfect. All right, and we'll look at a full code example as well. Um, okay, so we've got our monster side and our monster visitor, and then we connect these by passing in a visitor, one of these types of visitors, right? Whether it's a draw or fighting or whatever, into our monster classes to perform the actions. Okay, so it looks something like that. And then we update our goblins, right? They must implement the accept, and the orcs must implement accept as well, right? Because that's from our interface. Okay. So again, it could sort of be read as I accept some functionality from the monster visitor hierarchy, right? I'm taking in some functionality here and passing it into the class. I'll make this bigger later, but you can look up the slides if you want. But there's basically just an accept function implemented under orcs here. Okay. And then the important observation again is per behavior that we add. So let's look at this draw monster visitor, which is its own class, or fight monster visitor. Now I'll implement a visit member function for orcs and goblins. So what do orcs do? How do we draw them? What do goblins do? How do we draw them? Or if I have a fight monster visitor, how do orcs fight? How do goblins fight? Okay. So now all of our behavior related to orcs and goblins, or really any type of monster, right? Because this is a monster visitor, are in this one class here. Okay, which is sort of organized. I sort of like that, right? I've got my orcs and goblins, and then if I add dragons and trolls, right, all that behavior is here, probably in the same file. Again, nice and easy to see. Okay, so here it is. I'm just going to put that code snippet here. So this is something you can, a slide you can zoom in on later. Now, importantly, again, the purpose of this code, and again, wondering, why go through all the trouble, is for extending. That I would say is the main advantage of this pattern, as you folks observed. This is something known as the open-closed principle, which is one of these principles that tends to be a good thing, meaning this class here, right, the right side of our hierarchy, the monsters, they're closed in the sense that we're not modifying, right? I'm not adding other member functions to them. And that's generally good, right? With software, I mean, software is supposed to change, right? Software has the term soft in front of it for that reason. But if we have a lot of moving pieces that are changing, that's difficult. So we sort of want this right side to be closed off, but open to extension. And we open that extension by building these little visitor classes here. Okay, that's the idea. So effectively what I've done here with this visitor pattern is all my algorithms for how I draw things or how the monsters fight, they're separated from the object, okay? We've sort of gone away from the object-oriented programming, right? Where the behavior and the data, are separated now. And that actually can be a good thing for us because it can allow things to be extended a little bit more easily. But we are using object-oriented tools like having an interface, for instance, um, to code against, okay, for accepting and visiting, okay? Okay. Um, Now, as I mentioned, though, one of the things to keep in mind with the visitor pattern, and this is just a trade off, is we probably want to make sure we're not adding tons of trolls or dragons or something through the project, because that means we will have to do a lot of work for our monster visitors classes, right? If I decide I'm going to add dragons here all of a sudden, I need to add a visit dragons, and I need to implement that everywhere. Now that's sort of good and bad, right? We might just need that other monster, which is fine. Um, and the good thing is, by coding to an interface, it ensures we don't miss something. Meaning, we don't forget to implement draw, we don't forget to implement fight, or these sort of behaviors don't go missed. The I guess bad thing is, if we might be changing a lot of code if we're doing this frequently. So usually you kind of implement the visitor after your code's stabilized a little bit, right? You've thought about monsters, or otherwise how to generate this hierarchy in another way. And there's different patterns, like a type object pattern, for instance, which are useful if you need to generate lots of different goblins and orcs and so on. So, anyways, just a little aside there. Okay, so let's actually look at the code today here. And let me go ahead and open this up here just to show you a full example. And again, this is provided in the GitHub, so you're welcome to look at that at any time here. And I just want to show a full example, before we get to wrapping up here, of the code here. So I'll make it a little bit bigger here for our live example. But again, where we started out here was basically with our monster class here. And then we had our orc here and our goblin. Okay. And at first, again, our orc was just this simple thing, right? We didn't have any of this, right? It was just a class here, or a struct, right? Same thing in C++, effectively. But now what we're doing is we've added this accept here. So this is where we're accepting the actual functionality and saying, okay, we want to take in some behavior here from this visitor class here, right? It's visiting this class, right? For tossing in some behavior or algorithm temporarily, right? It doesn't belong to it. That's why it's called visitor. And basically all we're going to do is on our visitor here, call the .visit function here, okay? And you reference the object that we're taking in, that's this orc, and just pass that in here, okay? All right, so what does this monster visitor look like here? Let's go ahead and, well, I could show you the interface I get for monster visitor, which just says, yeah, we need a way to visit orcs, and we need a way to visit goblins, okay? And again, if I call visit on this object, this is where the virtual or the dynamic dispatch says, I know what kind of object it is. It's an orc, so I'll call the correct orc visit function here. Okay, so that's what's going on here. Okay, now let's look at these draw monster visitors. Now they inherit from this visitor interface, and that's how we're able to, again, if I scroll up a little bit, take in any monster visitor, right? Whether it's a draw, because it's a type of monster visitor, and I implement the visit here. So what happens when I want to draw the monster, particular orcs, maybe they have a routine here, that is handled, okay? So we just go ahead and do that. And then we do the same thing for goblin, right? The different ways to draw a goblin. Okay, and that's pretty much it. And then we do the same thing for, well, if I want a fighting behavior, I implement the visit for orcs and visit for goblins here. Okay, and feel free to ask questions at any time as I'm sort of going over this. I see one, I'm pausing as I see one question coming in. Let's see. Yeah. Comment nice pattern. Instead of forcing all classes to implement the behavior, we're giving them the ability to choose if they want to implement the behavior or not. Right. Correct. Yep, that is correct. Now there is a slight caveat though. I mean, we do have to implement for orc and goblin. They could do nothing. That is possible, right? We could just return a message that says goblins don't know how to be drawn or goblins don't know how to fight. In that case here. So yeah, we do have to implement visit for all of these types, like goblins and orcs and dragons and so on. That is a requirement because that's part of our interface here, right? We must implement visit for orcs and goblins. Now, that's not to say I could, again, depending on your hierarchy, I could have another visitor type, for instance, that only orcs accept, but goblins don't. So I'd write another member function here called accept, and let's just do it as an example. So I could write void accept, file system visitor, like this. And maybe, goblins don't accept that type of thing, right? Or the file system is saving orcs or loading different ones or something. So we do have quite a bit of flexibility there. And then the comment is following, aren't we still repeating the same code over and over in our visitor classes and structs? Potentially. Yeah. I mean, we could be doing some, you know, this is where we have to be a little bit careful. Now, do I want, draw might be something that I actually would just, maybe there's just one way to draw given data, right? This could just be a free function, right? Where I just take in some data for the 3D object, the texture, and so on. But if the behaviors are different, like how orcs and goblins fight, right, we're going to have maybe some different logic in here. I would say here we might, for draw maybe isn't the best example because we are, maybe repeating what we're doing here. But I could also just have a generic visit function as well that just accepts monsters. That could also be possible. Let's see, another question. What if I wanted to implement a certain behavior only if a certain condition is met? Do we need to do that in the definition of the visit function? Yeah, so there's nothing limiting us, for example, for passing in other states here that we might want. If we've got the goblin might have other state information, right? I am passing a reference to it here. So we might say if our goblin's health is greater than 50, battle in this way. If it's less than 50, battle in that way. So we do have some state information that we could pass, right? That's certainly possible. Yep. And this is actually one of the trade-offs with the pattern to SMJ's question that was just asked is, how much state do we want to pass around, right? The goblin might have some public data. We might have to add, a getter function somewhere in this class that says, return goblin health or whatever. So we're exposing potential details. We want to tend to avoid doing that because the whole point of this pattern is to just be able to extend the behavior, right, by writing these visitor classes. So again, it's a little bit of a careful walk you have to do, but this could be, again, a great way to just add your behaviors. Again, just looking at these classes, goblin and orc, I mean, these are effectively done, right? I could probably add, just as an example here, right, we had that attributes here, right, my data, and maybe we'll make it private, maybe it'll be public, but that's really it, right? We would have our attributes and accept the visitor here, and all of a sudden I've got, a new orc here, or a new data type, okay? And they look relatively simple, and as mentioned, you can accept different type of visitors. Let's see, I just remove that. So that's how we define, well, does an orc have behaviors for monsters or file system or whatever here? That's the idea. So it's really kind of neat here. Our other tool to do that if we wanted to add behaviors would be maybe you could use multiple inheritance, right? We could say, well, I want other behaviors, so take in, like we said, evil and I don't know, rendering or whatever. But this tends to be a little bit messy here when we get to multiple inheritance. So we tend to discourage that in C++. That's not a great way to extend classes because that becomes unclear of how we're extending it and so on. All right. All right. So that's sort of the code review. And again, just a summary of, what was going on here, how we're extending our functionality, some examples of that, and then actually let me show one more from the source here, one more example, how we actually use it. Because again, I have a free function for drawing all the monsters, maybe they're in some vector, and we just accept a visitor, right? This is the behavior that I'm sending in here. Or if I'm having all the monsters fight. Or let's go ahead and modify this further. Let's just go ahead and, write some other function. I'm just going to call it, process all the monsters. Okay. And I'm going to accept, that they, let's draw them first. Right. And then let's simulate them fighting or making a decision about fighting or singing. And we could also do other interesting stuff like say if, m, how do I want to do this? Right, we could have some state and basically say if m, right, we'd basically do a dynamic cast and see if we could successfully cast, and this is getting a little bit into the nitty gritty C++ stuff here. Let me just do it as a quick example. But we could say if we're able to cast a goblin or whatever our monster is that we're looking at in this loop to a goblin, then have some other behavior, right? Do something else and accept some other behavior, right? So that's a way that you can, again, use the runtime polymorphism to determine different behaviors. Again, someone was asking about different conditions or states, right? Maybe you want your goblins to do different things at different times, and so on. Now this has a cost here, what I'm highlighting here, dynamic cast here. And in fact, this whole pattern has a cost, okay? So we'll talk about that in a moment here. But back to the slides as we're getting near the finale here. So, summarizing this pattern here, what do folks think? Pros and cons. Did they buy it? What are folks' thoughts on this? Pros, cons? Do they feel neutral about it? Give folks some time to chat. It's a big question to think about here. Let's see, some pros coming in. Makes it more structured. Yep, I agree. And the cons could have us writing more code than normal usages. Yeah, I think that's fair, right? As mentioned, right, if I add a dragon and it doesn't have to fight, for instance, well, that's just going to be an empty function, effectively, that we don't need. And there is some nice structure, though, as mentioned, in that we can just basically add behaviors whenever we want without changing the structure of our actual classes in any ways, which is great. Let's take a look here. That's some things that I've summarized. And then neutral, yeah, could make debugging easier or harder depending on how it was written. Yeah, I agree. Again, looking at this code, it's nice to just look at a visitor class and say, hey, there's something wrong with, uh, how our objects are fighting or drawn. Or if I take a look at, this little function that I wrote here, process, this is pretty clear to see that we're going to draw things and they're going to fight and, sort of run things in this order here. I think that's pretty neutral. In fact, this is a nice way to process things. In fact, I don't have to process these all at once either. So let me just show you at the bottom here. If I just create a new goblin here, and then I create this behavior for, the visitor to do fighting, I could say, okay, now my goblin's going to fight here. Okay. So I've actually seen some nice code in games in particular where you can wrap up these things or these types of behaviors in coroutines or different threads that will just execute, a series of behavior. So you can do some really nice stuff here. It lets you play with your code quite nicely. But anyways, on to the pros and cons here. Again, it's easy to extend. The details are isolated from the class, and again, potentially we're avoiding repeating our code as mentioned, but maybe we're also writing more code, so it's sort of a neutral. The cons, it can be a little bit hard to introduce new types potentially. Again, if it's not any more difficult to write the code, but it is sort of saying, well, if I add a dragon here, now I need to implement, 50 visitor classes or whatever. So that could provide resistance or friction just from a psychological standpoint. You have to use the public interface, which may be good, maybe not. And one of the major cons here is, there's probably lots of performance loss for all the dispatch, meaning, figuring out, well, I've got a monster visitor and then I've got a fight monster visitor or draw monster visitor on one hand. So basically, at both sides of the hierarchy, you've got virtual functions. We call this double dispatch, which is a great and very flexible programming tool. But from performance, especially for games, that's something that we might want to think about. Okay, so we've got a really flexible system. There might be other ways that we want to design around this. Okay, so I've got a little bonus here. If I could spend just 1 minute on it before I wrap things up, and kind of circle back to, this whole, why did Mike do this introduction with functional programming, is I want to show you another way to implement the visitor pattern here. I'm just going to show you the code briefly here. And it's just called the sort of the functional visitor here. Oops. Functional, let's see, visitor. There it is. And I want to show you, or maybe get your thoughts here on what you think here about this pattern here. Let's see if I can make it a little bit smaller. It's actually small enough I can fit this all on one screen, I think, for you folks here. And we're going to revisit our acting example where I just have a struct for the method actor, a struct for the classical actor. I'm going to use this tool here called a variant. Has anybody seen variant before or heard of a tagged union or a discriminated union in any programming languages? Or a sum type? Maybe some folks have heard of. No, all right, great. Glad to be showing you some new stuff. Give you some homework to check out. I'll describe what it does here. Let's see. I think it's been to C++ after C++ version. Yeah, correct. So C++ 17 added this. And most compilers now have this supported. Standard variant. So let me tell you what this is. A variant here can be one type or the other. A method actor or a classical actor. Okay, it can only be one of these at a given time here. It's basically a union, if you've seen those, but it's type safe, meaning it can be either this or this. Now that kind of looks like our object-oriented hierarchy, right? Where we had monsters. In fact, let's go ahead and open up a slide here, right? A monster can either be a goblin or is a orc. Okay, that's basically the exact same thing that this variant is, right? It's one of these types or the other. So that's kind of like using inheritance without having to use inheritance. In fact, I don't see any inheritance in here, right? There's no base classes, so that's kind of neat. Okay, so now let's see what else is going on here. So if I actually use this variant here, which I've abbreviated or made an alias here and called actor, so it's sort of like a type here, but it's basically just plugging in variant, one of these two types here. And this time I'm choosing myself, Mike here. And now I'm going to use this standard visit, which is something that's part of C++. And basically, um, what visit does is it takes in a struct here with various function calls here. So here I have a visitor struct here for how I want to practice acting. Do I want to practice like a method actor or a classical actor? And this looks pretty similar to our visitor classes that we designed here, where I have just two functions that I call based on if I'm a method actor or a classical actor. So if I'm an actor that's at the current point in time acting like a method actor, and I call this visitor pattern, well, it's going to call the appropriate method actor function. And if I create another actor here who's a classical actor and I call visit on it here, it's going to call the appropriate classical actor. So where I'm kind of wrapping this up is if we just think about how we package data together, there's different ways to approach the same problem. Again, it depends on what we need to actually do, but this is just another implementation, a different way, but this is sort of more of a functional style, I would say, of approaching the visitor pattern here. Now, the other pattern perhaps gives us a little bit more flexibility, the object-oriented, and building hierarchies and forcing us to implement, certain functions. But this is effectively the same thing, right? Visitor patterns pervasive enough that C++ added a standard function for visit, which is kind of neat here. Okay, so now that you understand or could review the notes on the object-oriented solution, you can take a look at this variant version here, which is using a different tool, a variant, to sort of implement how we do or use the object-oriented inheritance strategy. Now, the advantages, or maybe some pros and cons of this strategy is, well, there's not as much of that dynamic dispatch going on, right? It's sort of only at one level here where we're figuring out what type of object we have, right? Because the variant can concretely only be one thing at a time. It's either a method actor or a made some sense with that last example that I showed you that we can think about things functionally and in different strategies. We spent our time looking at a real world problem that hope was motivating or fun, or hopefully you'll at least just watch Lord of the Rings, the movies, and appreciate those. And we learned about a pattern today, the visitor pattern. It's not perfect, but it is a pattern that if you need to extend some system, especially if a system's already been in development, it can help manage your complexity. And it's also not a bad pattern to look at if you just want to, even from the start, design a system that's extensible. So maybe you're going to allow your users to define new behaviors, and you can do that. So the visitor, it's a great exercise in understanding how flexible software creation can be, and also just understanding different programming paradigms. All right, so as mentioned, I have a bunch of other design pattern talks and thoughts here that you can take a look at. I'll link these slides and the source code on my website, which you can also check out. And again, I just want to really thank you for the gracious invitation. It's been an honor to speak with you folks at the College of Farabi, University of Tehran today with your Computer Engineering Scientific Association. The pleasure has been mine. Thank you for your patience with my cold and your questions throughout. And I'm happy to stick around as long as folks would like to chat today. So thank you.